If you're trying to do some graphing or sketching of a quadratic polynomial and you have no idea where to start, or maybe you know bits and pieces of it but you're not able to put them together, then I can guarantee that you're now at the right place. So what I'm going to do is I'm going to break that topic down into much simpler topics or steps and do multiple videos so you know what you're doing from the get-go. In this video, we are going to plot and see how a quadratic polynomial could look like and also identify the key features from the graph. To begin with, we are going to start with the most simplest quadratic polynomial. We all know that quadratic polynomial is a polynomial whose highest power is 2. So the most simplest quadratic polynomial here would be y equals x squared. Let's try to put in some points for x and find out what is the value for y. So we are going to create a table of values. So for that, I'm going to pick some positive values, 0, and then some negative values as well. So let's try and do maybe 0, -1, -2, +1, and +2. So as we keep substituting here, let's say if x is -2, then y would be -2 raised to 2, right? So -2 squared would be +4. Same way, if x is -1, y would be -1 squared, that's going to be 1. And if x is 0, y is going to be 0 squared, which is 0 again. And then if x is going to be 1, y is going to be 1 squared equals 1. And if x is 2, y is going to be 2 squared, which is 4. So let's fill this up. So for -2, we got 4. For -1, we got 1. For 0, it is 0. For 1, it is 1. And for 2, it is 4. So let's try and plot the points. So I'm going to enter the table of values here. So you can see the plotting happening as soon as I finish entering. So the first point is -2, we got 4. So you can see -2, 4. And then -1, we got 1. For 0, we got 0. And then 1, we got 1. For 2, we got 4. So these are the table of values. Now you can see the graph is clearly not going to be a straight line when you join these dots. Let's see how it looks when we join these dots, all right? So this is how the graph looks after we join the dots. So this shape that you see in here is called as a parabola. Now let's try to learn the features of a parabola, which is the most important thing when graphing. Look at the first parabola here. So this is the parabola y equals x squared. And we are going to try and see what are the different things that you can identify from the graph. So you can see that this graph is closed at the bottom and you can see it is open towards the top. So when we have a parabola that is open at top, we call this in mathematics as concave up. So if the parabola is facing downwards and if it is open downwards, we call it as concave down, which we will see in the next graph. Now the next thing is we are going to see where this curve is going to intersect the axis, the x-axis and the y-axis. So we know that the horizontal axis is always the x-axis and the vertical is always y. Now we'll see at which points the graph is going to intersect the y and the x-axis. So first we'll find out the y-intercept. So y-intercept is where does the graph meet the y-axis? So you can see it meets here, right? So this point. So that's basically both x and y are 0 there. So y-intercept is 0. Same way, now we are going to find out the x-intercepts of the graph. X-intercepts, again, wherever the graph meets the x-axis. So again, you see it meets only at one point, which is 0 here. So that is also 0. The next thing that we see here is, let me change the color so you can see it better. So you can see that when the curve starts from here, you can see the curve is actually moving downwards. And after hitting a certain point, you can see that the graph basically moves upwards from here. right? So there is a change in direction. So after taking a turn here at this critical point, it is going to go upwards. So this particular point, as I said, the graph takes a turn. It's very simple. So it's called as the turning point. So this point is called as the turning point of the parabola, or it can also be called as vertex. And there is also another term to it. So since this graph is open upwards, since this is concave up, you can see that there is a minimum point where the graph actually hits and then takes a turn. So beyond this, there is no line of graph, right? So this is the minimum value, minimum point. So we call that also as minimum point. So we can say that the turning point or vertex or the minimum point of this graph is, since it is a point, it has to be written in coordinate form. So x comma y, you can see that point is basically the origin. So origin is 0 comma 0. That is it, right? So now we have identified three main features. Moving on to the fourth feature, which is one of the most important feature as well. You can see that all these parabolas, you can see that they are symmetrical. So here you can see that this particular line in the middle, which is the vertical line, you can see that it divides this parabola into two equal reflective halves. So this particular line has a name. The name of this line is basically called the axis of symmetry. So why is it called the axis of symmetry? Because that's the line, the axis that is going to divide the parabola into two reflective halves, the ones that I've shaded in green. So this particular axis will have an equation. Every axis, every line has an equation. Now this line here is basically the y-axis. Every point on y-axis, x value will be 0. So whatever is your x value in that particular line is going to be the axis. So here I'm going to write it as axis of symmetry is x equals 0. So these are our main features of a parabola. So you need to find the y-intercept, the x-intercepts, turning point, and the axis of symmetry. We're going to try the same with different types of parabolas, so you know what clearly these features mean for each of them. Now look at this graph. So as you look at this graph, the first thing that you identify is the graph is downward, right? So it's open downward. So what is the name of it? It's called as concave down, okay? And then we identify the features. The first feature that we identify is the y-intercept of the graph. So what is the y-intercept in this graph? So y-intercept is basically wherever the graph meets the y-axis. So you can see the y-intercept is here. So that's basically 0. Now the next thing is find out the x-intercepts. It can be one or more. So you can see here it's meeting twice. So I'm going to put it as x-intercepts are. So you can see the graph meets the x-axis at 0 and also at 2. So I'm going to write that as 0 and 2. So I've done my y-intercept, I've done my x-intercepts. Now we move forward and try to find out the turning point. So again, you can see here that the graph goes from down to up, and then it reaches a certain point and then the direction changes. So this particular point is called as the turning point, right? So turning point or vertex, and it's going to be a point. So it's going to be x comma y. So you can see this point is basically 1, 4, right? So we write it as 1, 4. So that's the vertex. Now you can see that compared to the previous graph that we had, in the previous graph you can see that it was an upward parabola. It was a concave up parabola, right? So the graph reaches a critical point at the bottom. So it's called minimum and we call it as minimum point. Here the graph is upward. So it reaches a certain maximum and then goes down. So this is also called as a maximum point. All these three means the same: turning point, vertex, minimum or maximum based on the graph. They are all the same thing. It's just the point, the critical point at which the parabola changes its path. All right. The last thing is axis of symmetry. That's the last feature. Axis of symmetry. Now, axis of symmetry is the line that is going to divide the parabola into two equal reflective halves. So you can see here that the vertex basically lies on axis of symmetry. So I'm drawing from there. So how do I know what is the equation for it? I need to find out what is the x value here. So the x value here is 1, right? So x equals 1 is the equation of that line. So that becomes my axis of symmetry. That is it. So these are the four important features of a parabola. So you can try this for yourself, find out the features, and you can leave the answers in the comment section. I hope you were able to understand the features of a parabola, and this brings to the end of part 1 of graphing. Now the part 2 of graphing will involve transformations of a parabola, where we will discuss about dilation, translation, and reflection of parabolas. Thank you so much for watching. If you liked this video, please give a thumbs up. And if you have any questions, please leave them in the comment section and I'll get back to you shortly. If you want to learn more and make maths easy, then please follow Lee.